Chapter 2, Algebra Skills. Oh, the first section is complex numbers. I'm thinking we talked about this already. Remember? I. My computer won't make the I that way, so that's the way you'll see me do it all the time. Okay? Oh, again. Okay? All you need to remember is no, that's not right. Okay? I equals the square root of -1. Okay? Now what I'm going to do at this time right here is I'm going to square both sides. Okay? So I squared equals -1. That's all you need to know about complex numbers. If you can memorize that, you should be good. I squared equals -1. The symbol I was created to solve equations containing radicals involving negative numbers. Okay? I gave you an example of here. How would you solve the square root of -4? Huh? Well, if I'm right here, right, if I take x squared equals -4, and I take the square root of each side, x is equal to plus or minus -4. Well, what is plus? I don't know how to solve that. Okay? Now, I want all of you to graph this one. Just graph y1 equals x squared plus 4. Okay? That should be your graph. Now there is a graph here. Everyone sees this, right? Okay, now when I go back here to the smartboard, this graph does exist, but we can't solve it using real numbers. The reason you can't solve it using real numbers is this does not cross the x-axis. Do you see that? Okay. Now, if this did cross it, you would have solutions here. But here, it never crosses the x. So we have to use complex numbers. And remember, what's the one thing we'll solve this one right here. What's the one thing you have to remember about complex numbers? I squared equals, okay? So I can break this up. That's -1 times 4. Is that true? Okay. Instead of a -1, I can put in I squared. What's the square root of I squared? I. What's the square root of 4? So you put the 2 in front. And that is your answer. In other words, the quick way, this is a long way to break it up. The quick way is, boom, I say take out an I. Kind of like the Christmas story, you know, you begun. Take out an I. I'm left with the square root of 4. And what is the square root of 4? 2. Okay. So I have a few of these for you to try. Go ahead and try those. All right, so basically I'm taking out an I first. What is the square root of 16? 4. I'm not using plus or minuses here. There's a difference. Okay, what's the difference between this and the plus and minus? I was solving, okay? Now I'm just simplifying. This one, remember, if you don't remember how to do radicals, 2, 36, 2, 18, 2, 9, 3 is the smallest number, 3, 3, 1. I'm looking for pairs of numbers. 2 times 3 is 6. I'm left with a 2 inside, and I put an I there because it was a negative. This one here, I can break it up. I'm going to do each one of these different ways. 25 square root 2. Okay, first thing I'm going to do is probably take out the I. What's square root of 25? Times 4. Okay, you can do either method. You can do this method, or you can do this method. I think this method's easier. Okay, now 121 is a perfect square. So first thing I'm going to do is take out an I. The square root of 121 is a hockey number. Okay. Now the next group is something different. What does it say here? Solve. So now you do your plus or minuses. So I'm going to subtract a 20 here. X squared equals negative 20. I'm going to square root both sides. X is equal to plus or minus, Cody, negative 20. Okay. I'm going to pull. Okay.
Where do you want it?
Well, let's put it on my desk. Okay, I'm going to go ahead and take out the I first. What perfect square lives in 20? 4. Square root of 4 is? Okay. So that would be your answer.
It says keep.
What?
Put in your refrigerator.
I don't think that'll fit in my refrigerator. And I don't think it's been refrigerated all day, so I think we're okay.
The shop is pretty cool.
Well, thank you for proving me wrong again, Aaron.
Ah, girl, Aaron.
Now I'm going to subtract 90. I have 2x squared equals negative 90. I'm going to divide by 2. Divide by 2. X squared equals negative 45. Okay. Square root each side. So I have x is equal to plus or minus I square root 45. So I took the negative out right away. 9 is a factor of 45, and the square root of 9 is 3. So we should have that. Okay? Which is nice.
Suck.
We did these last year, didn't we? No? Huh. Thought we did. I stand corrected. Okay, so here it is. Complex numbers. In your 9th grade, 10th grade, and 11th grade, you dealt with the real numbers. You dealt with the natural numbers, the whole numbers, the integers, the rationals, the irrationals. What's an irrational number? Never ends. Like pi and e and the square root of 2. Okay? And you built your whole life on this side. But now there's an imaginary side, as we just saw. And they're called complex numbers. Every number is a complex number. Okay? Every number is a complex number with a real solution and imaginary solutions. Remember, you have your real plus your imaginary. Okay, this is where we're going to get into the different world of math. And I'm saying every number can be written as a real number plus an imaginary number. So, if you think about this, my hockey number can be written as a complex number. Remember, the complex has a real part plus an imaginary part. Well, my 11 is a real number, so technically speaking, that is how you would have to put it on the back of my jersey. If we were dealing with all the numbers. 11 plus 0i. So what does 0i equal? 0. Okay? So, technically, that's why in sports you just deal with real numbers as opposed to complex. Now, everyone says, well, you never use imaginary numbers. Well, every student that's ever gone into electricity uses imaginary numbers. Every engineer in the world uses imaginary numbers. So, the Ohm's law of electricity uses imaginary numbers. Okay. What we're going to see is you're going to see things like 2 plus 7i. Okay. This is the real part. This is the imaginary number. Now, all the things that you could do with real numbers, add, subtract, multiply, divide, you can do with complex numbers. Okay, so if I wanted to add two complex numbers, if I took 2 plus 7i and I added it to 4 plus 6i, what do you think you do? You're just going to add the real parts together first. 2 plus 4 is 6. Okay. 7i plus 6i is 13. Adding isn't too bad. We can also subtract them, so I could just erase this. And I put a minus. Now this is why we way back in Algebra 1 we taught you to do this. Change the signs, because you use it forever. 2 plus a negative 4 is negative 2. 7 plus a negative 6i is I. Okay? So you can add them, you can subtract them, you can also multiply them. So now, I'll erase that, take that. Oh, I was trying to move them closer together. I don't have the power to do that on my smart board. Okay? So how do you think you multiply those? You got to foil them. So you take your first, 2 times 4 is 8. You take your O, your outside ones. 2 times a positive 6i is positive 12i. You take your inside, plus 28i, and your last one's plus 42i squared. Okay? And James, what's the one thing you had to remember?
I squared equals, I squared equals -1.
Okay, so remember that when I call on you in a moment. We can add these together. Becomes what, 40i? Now, James, what does this become?
-1.
-1. So that becomes -42. Okay?
Add the 8, right? Now you can add the 8 in the...
Yep. So now I'm going to take the 8 minus 42 and get -36 plus 40i.
Wouldn't it be 34?
34! I can't subtract. Now remember, I will mark this wrong if you go 40i minus 32. 34, I can't get the number right today. Why would I mark that wrong? Because in complex numbers, what comes first?
Oh, yeah.
The real or imaginary. I will mark that wrong. So I would rather see this. I don't want to see that. So adding's cool. Subtracting's real easy. Multiply, you just FOIL. The dividing one is tough. Oh, we have to do that. 2 plus 7i. Let's see if I can remember that. 2 plus 7i over 4 plus 6i. Okay. In math, there's things you cannot have. You cannot have negative exponents. Okay. You cannot have radicals in the denominator. Remember that, right? You could not have that. How did we get rid of that? We multiply the top and bottom by what? Square root of 2. We got that over 2. You cannot have imaginary numbers in the denominator. Okay? This was called rationalizing. That was called rationalizing the denominator. We're going to do realizing the denominator. We're going to make the bottom all real. Okay? So the question is, how does one get rid of an imaginary number that's in the bottom? I'll give you a hint. You have to multiply. And you have to use the conjugate. Remember what the conjugate was? Remember when we had 3 over 2 plus the square root of 2, what did we have to do? We had to multiply by 2 minus square root of 2. Okay? That's the conjugate. You switch the signs. So for complex numbers, you have to multiply the top and bottom by 4 minus 6i. 4 minus 6i. And how do we multiply them? FOIL. So go ahead and give that one a shot.
I don't know if that's right, but.
Now, if you get really good at this, the bottom comes out really fast, and I always do the bottom first, okay? This is difference of squares, so a lot of people may just go 16 minus a minus 36. You'll get there at some point. Probably not right now. So I will do it for you. I'm going to take 4 times 4, which is 16. The outer is negative 24i. The inner is positive 24i. And the last one becomes negative 36i squared. Those cancel.
No, I thought the bottom canceled out.
Yeah, that's what I think.
And then you're left with, James, what does that become?
-1.
Right. And negative 1 times negative 36 is,
Positive.
which becomes 52, okay? Now, I showed you that reason because when I do these, I don't do all these steps. I just do the denominator right away, and then I FOIL the top. And I think after the homework assignment you'll be at the same point where this is what I would recommend doing on the bottom is 16 minus 36i squared. Okay? All you do is square this one, make it a minus, and square that one. The top now we have to FOIL out, which is 2 times 4 is 8. Outside is minus 12i. Inside is plus 28i. Last is minus 42i squared. Please don't cancel the I squares. Don't do that. Okay? So this becomes, a lot of people would start doing this. What does that equal? -1. That makes that positive. Does that make sense what I just did? Huh? Okay.
Alright.
So 8 plus 42 is 50. Negative 12i plus 28i is positive 16i. All over, well, I squared is negative 1. That makes that a plus 52. Now, I'm not done. Okay? When you have something like this, you have to look at all the numbers. Do they all have some factor in common? I can reduce all of them. I'm going to go by twos. Okay? 50 divided by 2 is 25. 16 divided by 2 is 8i. 52 divided by 2 is 26. Can I reduce any farther? No. There you go.
You're not gonna put the 2 anywhere?
Do I want to put the 2 out front?
2 anywhere?
No, I just reduced them all.
Just threw the 2 out.
Yep. It's like reducing this. That reduces down to 1/2. We don't throw a 2 out in front. Okay?
Didn't know you could take stuff out.
That leads right up to the quadratic formula we're getting to too.
Oh, it's just like that.
Okay? So,
Matt's going on the stage. The stage is more important than the hallway. And she's like, well, that's what he told me. That's going there. And I'm like, well, it's not. I have looked at another sheet of paper. Because she's like, we don't want to because it'll have a line.
let's all get along and be happy. I'm happy.
Yeah, I'm glad for you.
Eh. Oh, you're a funny guy.
I wasn't kidding.
You're funny.
Okay, I'm gonna call you Jordan.
Funny.
I'm gonna really call you Jordan.
You gas monkey guy's funny.
I really think you don't want to be called Jordan. Look at